Okay, Algebra 2, quadratic formula, Math Excel homework from 2.6.16. If I were doing a problem like this, just remember the quadratic formula. The coefficients are your a, b, and c. So ax squared plus bx plus c equals y would be your standard quadratic. So any number, if there is no number, like in this case, in front of the x squared, then what number would you put there? So when we're saying we equal 0 here, that's like my y is 0. So then that's like saying if y is 0, that's any point, yellow, that's a really big highlighter point. That would be any point that's on the x-axis, y is 0. So we're solving for the x-intercepts in this case. And if I were going to work this problem factoring, I would do this problem the fastest because of the fact that you could just do x plus 3 and x plus 3 and get a -3. So over here at -3, you're going to have one x-intercept opening up. So just keeping that in mind, if it says the quadratic, oh, wait, use the quadratic formula. So a would be 1 here, b is the 6, and c is the 9. And then just remember how the quadratic formula goes. I just remember it to this little song. You can look up Emily singing the quadratic formula on YouTube. She's about 3 years old probably, and she can remember it. So I would expect everybody else can as well. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And just take it away. So -b would be this -6 plus or minus the square root. B squared, you can write 6 squared. I'm going to go ahead and square that and say 6 squared is 36. Minus 4 times a is 4 times 9 would be 36. All over 2 times the a is just 2. Now, notice what happens in here. This is 0. That's what tells me there's only one x-intercept here for this graph, or one root, or one 0. And that's because of the fact that if you look here, when you add 0 or subtract 0 to -6, it would be the same thing either way. So -6 divided by -2, -3. That's what we got here when we were looking over here at factoring. That's what we wrote up here for my x-intercept. That's what we said we would sketch a graph that was right over there. So problem 2.6.16. Using the quadratic formula to solve the quadratics.